According to the National Fire Protection Association, NFPA 30, a code for Marina input odds, electrical conduits and feeders installed in the fuel dispensing area of a marina must be constructed of rigid metal conduit, RMC, and extend at least 2 feet beyond the fuel dispensing area. PVC conduits are not permitted in fuel dispensing areas. Therefore, the conduits in a proposed marina design must be RMC all the way through the fuel dispensing area. Let's delve deeper into why these regulations exist and what they mean for marina electrical system design. The primary reason for requiring RMC in fuel dispensing areas is safety. Fuel dispensing areas are classified as hazardous locations due to the potential for flammable vapors to be present. These vapors can create an explosive atmosphere if ignited. Electrical equipment in these areas must be designed and installed to minimize the risk of ignition. RMC provides a robust and grounded enclosure for electrical conductors. It is designed to contain any potential sparks or arcs that may occur within the conduit, preventing them from igniting flammable vapors in the surrounding atmosphere. PVC conduit, on the other hand, is not considered suitable for hazardous locations. PVC is a non-metallic material and does not provide the same level of protection against ignition as RMC. It is also more susceptible to damage from physical impacts and exposure to chemicals. NFPA 30 specifically prohibits the use of PVC conduits in fuel dispensing areas to ensure the highest level of safety. The requirement that RMC extend at least 2 feet beyond the fuel dispensing area is intended to further minimize the risk of ignition. This extension ensures that any potential sparks or arcs within the conduit are located outside the hazardous area, where flammable vapors are less likely to be present. In practice, this means that the RMC must continue beyond the defined boundary of the fuel dispensing area for a minimum distance of 2 feet. This may require careful planning and coordination during the design and installation phases to ensure compliance. When designing a marina electrical system that includes a fuel dispensing area, it is crucial to consult NFPA 30 and other applicable codes and standards. These codes provide detailed requirements for electrical equipment and wiring in hazardous locations. It is also important to work with qualified electrical professionals who have experience in designing and installing electrical systems in marinas. These professionals can ensure that the electrical system meets all applicable requirements and is safe for use. In addition to the conduit requirements, there are other important considerations for electrical systems in marina fuel dispensing areas. These include the selection of explosion-proof electrical equipment, the proper grounding and bonding of all electrical components, and the installation of overcurrent protection devices. Explosion-proof electrical equipment is designed to contain any internal explosions without igniting flammable vapors in the surrounding atmosphere. This type of equipment is typically used for lighting fixtures, switches, receptacles, and other electrical devices located within the fuel dispensing area. Grounding and bonding are essential for preventing electrical shock hazards and minimizing the risk of ignition. All electrical components in the fuel dispensing area must be properly grounded and bonded together to create a low impedance path for fault currents. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overload in short-circuit conditions. These devices must be sized and installed in accordance with applicable codes and standards to ensure proper protection. In summary, the use of RMC is mandated in marina fuel dispensing areas due to the hazardous nature of these locations. NFPA 30 specifically prohibits the use of PVC conduit in these areas to minimize the risk of ignition. The RMC must extend at least 2 feet beyond the fuel dispensing area to further enhance safety. When designing and installing electrical systems in marina fuel dispensing areas, it is crucial to consult applicable codes and standards, work with qualified electrical professionals, and pay careful attention to all safety requirements. Neglecting these requirements can have serious consequences, including fires, explosions, and injuries. By following the established guidelines and best practices, it is possible to create a safe and reliable electrical system for marina fuel dispensing areas. Furthermore, regular inspections and maintenance are essential for ensuring the continued safety and reliability of the electrical system. Inspections should be performed by qualified electrical professionals to identify any potential hazards or deficiencies. Maintenance should include the replacement of damaged or worn components, the tightening of connections, and the testing of overcurrent protection devices. By implementing a comprehensive inspection and maintenance program, it is possible to minimize the risk of electrical problems and ensure the long-term safety of the Marina fuel dispensing area. Now let's elaborate on some specific aspects of RMC and its installation. RMC is typically made of steel or aluminum and is available in various sizes and thicknesses. The size of the conduit depends on the number and size of the conductors that will be installed within it. The thickness of the conduit depends on the application and the level of protection required. When installing RMC, it is important to use appropriate fittings and connectors. These fittings must be listed for use with RMC and must be properly installed to ensure a secure and watertight connection. The conduit should be supported at regular intervals to prevent sagging and damage. The support should be made of a material that is compatible with the conduit and the surrounding environment. In addition to the general requirements for RMC installation, there are some specific considerations for fuel dispensing areas. Firstly, all conduit runs must be sealed to prevent the ingress of flammable vapors. This can be accomplished by using sealing fittings or by applying a sealant to the conduit threads. Secondly, all electrical equipment within the fuel dispensing area must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any internal explosions without igniting flammable vapors in the surrounding atmosphere. Intrinsically safe equipment is designed to operate at very low voltage and current levels, which are not capable of igniting flammable vapors. Thirdly, the grounding and bonding system must be carefully designed and installed to ensure a low impedance path for fault currents. This is essential for preventing electrical shock hazards and minimizing the risk of ignition. Fourthly, all wiring within the fuel dispensing area must be installed in accordance with applicable codes and standards. This includes the use of appropriate wire types, the proper sizing of conductors, and the correct installation of overcurrent protection devices. Furthermore, it is important to consider the potential for corrosion in marine environment. Saltwater and other corrosive substances can damage electrical equipment and wiring, leading to premature failure and safety hazards. To mitigate the risk of corrosion, it is recommended to use corrosion-resistant materials and coatings. This includes the use of stainless steel or aluminum conduit, corrosion-resistant fittings, and epoxy coatings. It is also important to regularly inspect and maintain the electrical system to identify and address any signs of corrosion. Another important consideration is the potential for physical damage to the electrical system. Marinas are often busy and crowded environments, and electrical equipment can be easily damaged by boats, vehicles, and other objects. To protect the electrical system from physical damage, it is recommended to install conduit in protected locations and to use guards or barriers to prevent accidental contact. It is also important to train marina personnel on the proper use and maintenance of electrical equipment. Furthermore, it is essential to have a written electrical safety plan in place. This plan should outline the procedures for operating and maintaining the electrical system safely, as well as the steps to take in the event of an electrical emergency. The plan should be reviewed and updated regularly to ensure that it remains relevant and effective. In addition to NFPA 30A, there may be other applicable codes and standards that must be followed. These may include the National Electrical Code, NEC, state and local electrical codes, and insurance requirements. It is important to consult with qualified electrical professionals to determine which codes and standards apply to the specific marina project. These professionals can also provide guidance on the best practices for designing and installing electrical systems in marina fuel dispensing areas. By following all applicable codes and standards and working with qualified professionals, it is possible to create a safe and reliable electrical system for marina fuel dispensing areas. This will help to protect people, property, and the environment from the hazards associated with flammable vapors and electrical equipment. Finally, remember to document all aspects of the electrical system design and installation. This documentation should include detailed drawings, specifications, and calculations. It should also include records of all inspections and maintenance activities. This documentation will be invaluable for future maintenance and repairs and will also be helpful in the event of an insurance claim or legal dispute. In conclusion, designing and installing electrical systems in marina fuel dispensing areas requires careful planning, attention to detail, and adherence to all applicable codes and standards. By following the guidelines outlined in this discussion and working with qualified professionals, it is possible to create a safe and reliable electrical system that will serve the marina for many years to come. The use of RMC throughout the fuel dispensing area, extending at least 2 feet beyond its boundaries, is a critical safety measure that must be strictly enforced.